This is Unit 1, Lesson 11, and we are talking about systems of linear inequalities. Okay, we have been talking about inequalities for several days now, so let's hope that you know what they are. Remember, they are those symbols greater than or less than, okay? We're always going to have some type of shading involved with our graphs. What happened there? Um, Linear, okay, I pointed out, I don't know why that's, oh, let me fix that. Shading involved, okay. I also point out to my people, linear, first four letters is a line, so if we're talking about linear inequalities or a system, the graph is going to be a line. And what does it mean to have a system of linear inequalities? It means you're going to have two or more equations or inequalities. So you can see from this first example here, there are three equations, but the graph of them will all be lines. So that's one thing to keep in mind when you do it. So there are only three problems in this lesson, but if you'll turn the paper over, the one that I want to start off with is number 3. I did tell my people to scratch out, write all of the answers in terms of pi. We crossed that out because I didn't want to scare them and think that anything was going to have pi in it. I took off the problem that went with this packet that was like that. So we're good to go. All right, so let's talk about graphing each of these. We reviewed using IXL and D7 how to graph lines, what they were. So this should go pretty quickly. So to graph x is greater than or equal to 0, I have a line. Let's go with this. Needs an arrow on both ends. And I'm going to choose a color. Let's go with that one. And it looks like this. That is x is greater than 0. Now, if you graph it on your axes and you can't see it very well, sometimes I will go ahead and write equals, write it on top of the axis so we know what it is. Now, x is greater than or equal to 0, greater than or equal to. So which side is greater than or equal to is this way. So I draw arrows because I think it can get a little hard to tell the region when I do a bunch of shading. So that's what that is. Now let's look at y is greater than or equal to 2x. Okay, so that is of the form, let's go get this color. All right, it's of the form y equals mx plus b. Okay, and we know that that means b is 0, 0. Why does it keep doing that to me? B is 0, 0, and the slope is 2, which is the same thing as 2 over 1. So we come over and we start at 0, 0, and I'm going to go up 2 over 1. Up 2 over 1, there's that black again in the middle of my thing. Up 2 over 1, up 2 over 1. So this is, and down 2 over 1. So that filled up my graph. Now I'm going to go graph this. Did they stay? Nope. And they are all equal to, so they're all going to be dotted, but we do have to shade. So let's figure out, it says y is greater than. So we talked about this last time. Y is all by itself. So I'm going to go greater than or equal to 2x. So I go to my y-intercept and I shade that part, that region that is greater than the y-intercept. So that's this way, which means that I'm going to be shading this way on my line. So we're looking like that. Now let's go to the last one, 2x plus y equals 7, and that is our standard form, ax plus by equals c, that we talked about graphing using our intercepts. And our intercepts, if I put in 0 for x, then y is 7. And if I put in 0 for y, that doesn't really look like a 0, my bad. If I put in 0 for y, then x is 7/2, or 3.5 if you wish. So I'm going to go to 0, 7, which is right here. And I'm going to go to 3.5, 0, which is 7/2. And now I'm going to connect those two to draw our line. And it will look something like this. Oh, I messed up there. Let's go fix that. All right, so that is, and now we have to figure out where we're going to shade. So now, in this one before I said, if y is by itself, then I can use the inequalities symbol to decide which way to shade. But y is not by itself. So the other method that you want to use is to plug in 0, 0 as long as it's not on your line. So if I put 0 plus 0, is that less than or equal to 7? Okay, the answer is yes, true, it is. And so I want to shade a region that includes, oh great, I want to shade a region that includes 0, 0. So I'm shading this way. So I'm going to go like this. So when you look at these, okay, you're looking for a bounded region, which means that it has a line that stops on every section. So if you look here, okay, yes, I go that way for the green and that way for the pink, but the purple didn't tell me to go that way, so it's not this region. There's no arrows pointing in here, only one arrow pointing there. So this is my region. So I'm going to go color that in. Okay, why did I just put a dot there? All right, so let's go color in our region. And then, okay, and keep in mind that the directions say graph the system. So if you do not shade, then you have not graphed, because these are all inequalities, and all the inequalities are involved with shading. So you're not finished until you have actually shaded. So please keep that in mind. Okay, now we're going to determine the vertices of our region. Okay, and you remember from geometry, a vertex is basically where two sides of your polygon, your region, intersect. So I'm going to label that A, and this B, and this C. So that's going to give me A has coordinates of 0, 0. B has coordinates of 0, 7. And C has coordinates of, we don't know. So you can estimate from your graph, but that's not going to be very accurate. So I reminded them there are two methods to figure out. What we have to decide is we have to find out where this purple line and where the green line intersect, okay, which is right here. And we don't know where that is, but we did learn a method for solving that in Algebra 1 and did it again in geometry. And what are those two methods? One is something called substitution. Who? He's doing that. Sorry, love technology, except for when it doesn't work. Substitution, we're going to go on. And number two is elimination. Okay, so what are the two things that we're solving? We have y equals 2x, and we have y equals, nope, it's not a y equals, it's 2x plus y equals 7. Okay, those are the two lines. So if you remember from substitution, okay, what was an easy way to do it is if you had a variable by itself, I like to circle what it's equal to. So y is equal to that. So I'm going to go plug it into that equation where y is. So that's going to give me 2x plus, what did I just plug in? Instead of y, I'm writing 2x equals 7. Okay, this has got to stop. 7. So 2x plus 2x is 4x is equal to 7. Divide both sides by 4, and x divide both sides by 4, and x equals 7 over 4. And they were quick to tell me, how do I find the other one? Is I just go plug that in. So when I plug it in, I'm going to find out that y is equal to 2 times 7 over 4, which easiest if you put that over 1 and simplify, that becomes 7 over 2. So the answer to our problem is x coordinate of 7/4 and a y coordinate of 7/2. That's what this is right here. So you put that in there and kind of go look and say, well, 7/4 is 1 3/4. Did I go over 1 3/4? It kind of looks that way. And did I go up 3 1/2? So that looks like an acceptable answer, and we'll go with that. Okay, now we have to determine the area of the region. Okay, the area of this region. What shape is this region? The region is a triangle. How do we find the area of a triangle? It's 1/2 base times the height. Okay, what is the base of my triangle? Well, we all agree that this is the base, and that distance is 7. So I have 1/2 times 7, and now I need a height. So if this is my base, then my height is going to be from the vertex perpendicular to the other side, and that's not very perpendicular. I'm going to try that again. There you go, that's better. So that's perpendicular. So how far is it from the y-axis to this point? Well, that's whatever my x-coordinate is. So that is going to be 7/4. Oh, no, I'm on pen. Come on back. All right, so that's 7/4. And when you multiply that together, we get 49/8, which is units squared because area is always units squared. If you like decimals and you have a terminating one, then I will take 6.125 units squared. Okay, so that's the area. The last thing we have to do, highlight the difference between those. So this is area and this one is perimeter. Okay, what is the perimeter? The perimeter, everybody knew, is what we get when we add up all the sides. Okay, so we've already discussed, all right, let's go start writing that. So the perimeter is, it's a triangle, so I'm going to add up all the sides. So I have 3 sides, 1, 2, 3. The one side, easy side, is 7, but I need to know what the other 2 sides are. Well, one thing that we realized is, or we know that the y-coordinate right here is 7/2 or 3.5. Well, if that's 3.5, then that means this side, this length is the same as that length because that's half of 7. So when you draw a perpendicular down and it bisects the side, then we know we have an isosceles triangle. So these 2 sides will have to be the same. And so what we did is we knew that we had a right triangle. We know that one side is 3.5. We know the other side are 7/2. The other side is 7/4. So we used something called the Pythagorean theorem. A squared plus b squared equals c squared to solve it. And we reminded ourselves that the longest side has to be by itself. That's what we're looking for. So we have 7/2 squared plus 7/4 squared is equal to c squared. Use your handy dandy scientific calculator to give you 245/16. And then when you take the square root of both sides, you will find out that c is equal to 7 square roots of 5/4. Because the square root of 16 is 4, this is 5 times 49, and the square root of 49 is 7. So both of those sides have a length of 7 square roots of 5/4. And again, if you have that nice scientific calculator that I recommended, you can put that in there and it will give you your answer, which is 7 plus 7 square roots of 5. Oh, goodness. 7 square roots of 5/2. And this is perimeter. Perimeter is not squared, it's just units. But that is our answer. And just real quickly, so to make sure you don't do it, whenever you have a radical, you cannot combine it with something that doesn't have a radical. So this stays by itself, but if you have 2 of these, then it'll cancel with your 4 when you combine it. So that's why it's 7 square roots of 5/2. So that ends our lesson. You will need this Pythagorean theorem on the other side when you try to figure out your perimeters, but the area problem and finding your vertices will be much easier. So I hope that helps you work through lesson 11, and come see me or email me if you have any questions. Thank you very much.